Hello everyone, this is Wilson. Welcome back to my 1 minute presentation. Today I'm going to talk about the file spread rate, or you can say that this is a file spread speed. So in the previous 2 days, I've already presented this topic, but there is some technical problems for the PowerPoint, so I cannot export the video from the PowerPoint, so that in the previous 2 days, I didn't upload anything to the YouTube. So today I'm trying to represent this topic again so that you guys can know more about what is the file spread rate. So let's get started. So when we talk about the file spread rate, it can be defined by equation. So let's say the file is spreading from point A to point B. So the velocity for the frame from moving from point A to point B can be determined by the length of the A to B. So this is a length from A to B, or you can say that this is a frame length divided by the time for the frame moving from point A to point B. So let's take a look to the point B. So why the file can be spread from the point A to point B? This is because the point B is ignited by the frame from the point A. So that means the time for the file spreading from the point A to point B is equal to the ignition time for the point B. So that we can say that the time of the ignition of the point B by the frame from point A is the same as the time for the frame spreading from point A to point B. So that the equation can be determined by the velocity of the frame spreading from point A to point B can be determined by the length between A and B point divided by the ignition time of the point B. So how to calculate the ignition time? So the ignition time can be determined by the volt times the thickness of the field times the heat capacity and times the ignition time minus the ambient temperature divided by the heat flux, the total heat flux. So the first equation is for the thin field, where the thickness of the field should be less than 2 mm. So for the thick field, which means the thickness is larger than 5 mm, can be determined by the volt times thermal conductivity times the heat capacity times the ignition temperature minus the ambient temperature square root and divided by the total heat, the total heat flux square. So for the thin field, the ignition time can be varied by the thickness of the field, while the thick field will be determined, the ignition time can be affected mostly by the material's thermal conductivity. So and then let's take a look at the point A again. Let's take a look at the point B again. So point B, as you can see, that is almost covered by the frame. So we can say that the heat flux of the heating is equals to the frame heat flux as the fire covered by the point B, and the heat loss can be equal to 0. So why? It is because the frame is almost covered the point B, so that there will have no convective loss or any other loss. So the main heat flux is coming from the frame. So in the denominator, it will be just the heat flux of the frame. Also here, it's just a heat flux of the frame. So after substitute the ignition time to the velocity equation, we can get these two equations. So The upper ones can be determined the thin film ignition velocity or the spreading speed, and the equation in the below is for the fixed film to calculate the velocity of the fire or the fire spread speed. So this is the end of my presentation. So I hope you guys can learn something about how to calculate the fire spread speed, so that if you are broiling at home, you can just try to calculate some fire spread from a wildland fire. It's quite interesting. So this is the end of my presentation. Thank you.